Hello, my name is Alasdair Nottingham. I work for IBM in the Liberty development team working on Jakarta EE and MicroProfile. Before I start, I just want to ask a question. How many people of you here read the abstract for this talk? Okay, that's more than I expected. How many of you came here because it had the buzzword Kubernetes in the abstract? Put your hands up. Okay, so I'm going to have to apologize to the one person who came here because it said Kubernetes, because when I was trying to go through the demo on my way to the conference, I discovered my complete Docker environment on my laptop was toast. So after I arrived here with both the hotel and the conference Wi-Fi, I have been doing my best to get it back set up, but I actually don't have any active working Kubernetes on my machine. I do have Docker working on my machine, but the Kubernetes part of it, I just didn't get a chance to get working. So whereas I wanted to talk and demo running some of this stuff in Docker and Kubernetes, the Docker and Kubernetes content of this session is, instead of being about this, is about this. So I just want to start by apologizing, and I will learn from the person who said, whenever you submit a conference talk, try to minimize the things that might actually fall apart on the way to the conference venue. In any case, I'm going to go on ahead, and I have some live coding demos, and if you have any questions, I'll be here or at the IBM booth afterwards. So just some background to cloud native, and this is my perspective. Other people will have different, but when I look about what's going on in cloud native and why people are so enthused about microservices, I look at it as kind of a continuum of some of the evolution of development practices over my career. So we started out with the idea of agile and extreme programming as a way to kind of make development fun for developers and also be more responsive to change and being more able to effectively manage our code development. And for a lot of people, that worked really well. For some people working in big enterprises where they had agile imposed on top, which is really not the way agile is supposed to work, things weren't quite as agile as they could be, but for people who really got the chance to do agile properly, it worked very well. Problem with a lot of teams with agile, though, is they would do agile in the development team, and then when they wanted to get things run up into production, they would hit problems because there was no kind of agile methodology for how you get things running in production. So DevOps came along and said, well, let's just treat operations as being like code, and then we can do that as in an agile way. And when we build and test our application, not only can we build and test our application, but we can have automated processes to deliver and run in production as well. And then, the cloud came along all at the same time. And the nice thing about the cloud is it makes it really easy for you to spin up and shut down instances of software, operating systems, and so on. So the combination of all of these really enable people to start thinking about software in terms of the newest buzz, microservices, because you can have this agile, independent development teams who own end-to-end the application end-to-end. They click a button, do a commit into Git, goes through all of the build DevOps pipeline. They can provision a server up and into a cloud, and they can treat all of these things as independently. So I kind of view this as being, it's a natural progression of a load of different trends within the industry that are going on. So what are good characteristics of a cloud-native environment? Well, generally speaking, you want something that provides a good set of APIs for distributed computing. I say this because distributed computing is difficult. It is not easy. It is much easier to make a method call in Java than it is, reliably, than it is to make a call to a foreign service run by another team that might go down for whatever reason. So you want APIs that actually make it easy for you to do distributed computing, because then you don't need to build so much of the capability into your code. You want something that starts up and shuts down cleanly, and this is because when you're pushing updates, especially if you're doing continuous builds and continuous delivery, you want those to be stood up and deployed into the runtime very quickly. You don't want to find that your server takes 15 minutes to restart because of an application update. You want a small footprint. Cloud resources are not cheap. They're not expensive, but they're not cheap. So you want something that doesn't use a massive amount of resources because you tend to pay based on what resource you use. And you want something that enables you to have kind of fidelity between your development and production environments. You want to be able to externalize the configuration. So instead of having to rebuild your application every single time, you can just change some configuration, and then it's working in a slightly different way, talking to a different database, different instances of services. This is perhaps this is something that some people might debate, but being containerized, easy to containerize, is important. I say some people will say this is up to debate because there's a lot of people out there who use Cloud Foundry and will say, well, I just push my application. I don't containerize anything. Cloud Foundry containerises in the background. So an application that containerizes very well makes it very easy for your application to essentially be pushed around in a cloud environment, scaled up, scaled down, if there's a failure occurs, to restart. So that's actually really important, even if you're not aware that the container exists. So this is really a talk about kind of how to do it with MicroProfile, how to do cloud with MicroProfile. So I want to talk a bit about why the Eclipse MicroProfile project exists. And, you know, last year we started, Oracle started a process of transferring Java EE to Jakarta EE. But if you look at this chart, it kind of shows the history of Java EE releases, which is a big reason why we decided we were going to go with do MicroProfile. So if you look along this here, it doesn't have Java EE8 on this chart, but if you look along the bottom, you'll notice that there's a big delay, there's a big time between each of those releases. You know, it's 3 or 4 years between a Java EE release. The thing is, how many people think that the industry is moving with changes being, you know, taking a 3 or 4 year period as opposed to a year or 6 months or 3 months in some cases? You know, the industry is moving to cloud much faster than Java EE standards were able to keep up. So a group of companies involved in Java EE got together at a Java, it was either a Java 1 or a DevOps conference, and said, we need to do something to kind of speed this up. We can't speed it up within Java EE, so why don't we start a new project to define new APIs to make distributed computing easier? And that's where Eclipse MicroProfile came from. So it kicked off as a practice to say, okay, well, we're not going to get a JCP standard fast enough, but maybe if enough people got together and agreed on the APIs and there were enough implementations, that would be good enough for most people to use. And in Liberty, we realized this using in our Liberty runtime. So we've implemented MicroProfile in Liberty. We have the concept in Liberty of features. So you can be really fine-grained and say, this is the parts of the specs you want. So you can actually compose arbitrary subsets of the Java EE and MicroProfile specifications. You don't have to take it all. And it's not just us that have done this, because Wildfly Swarm, now Thorntail, essentially has the same concept. They have fractions, which are the same as the Liberty features concept, and they can allow you to have any mix and match of the Java EE and MicroProfile capabilities you might want to choose. So there's a lot of different options for how you would build an application that uses MicroProfile and Java EE, and you don't have to just be bound by the specifications in Eclipse MicroProfile or Java EE. You don't have to consume everything. That's really nice because it means that you can have an application runtime that is tuned exactly to what you need. Typically, you throw more stuff in a box, it takes longer to start, it uses more CPU capacity, but everyone is now allowing you to kind of mix and match. So I've kind of already done Eclipse MicroProfile. And it's not just IBM and Red Hat. This is a little bit out of date, but we've got Tommy Tribe and Pyara are implementing this as well. We've had some involvement at some time from Hazelcast. I think, oh yeah, we've even got kind of Microsoft. And Lightbend are involved, and Lightbend are the people behind the Play framework and Legom, and there's something else that I've just forgotten. So it's not just kind of traditional Java EE companies that are getting involved. And the really nice thing about Lightbend is they really want to see reactive programming getting into Jakarta EE. And they're doing that through the Eclipse MicroProfile project because they recognize that if they did it in, if they tried to do it in Jakarta EE, they would almost certainly not have started the work yet. So, and you know, that's not because Jakarta EE is sitting around doing nothing. It's just the focus at the moment is still getting everything from the Java EE into the Jakarta EE brand. So if you're building one of these cloud-native applications these days, there is a very good chance you'll be using REST APIs. And Eclipse MicroProfile has kind of a set of, an opinion on what is a good set of technologies to build REST APIs. There is CDI as the component model. I really hate the CDI name because nobody seems to know what it means. Me included. But it's basically a lightweight bean model where you can kind of annotate beans, and it's very powerful, but its name is not really as cool as it could be. Then there's JAX-RS, which is the way of indicating that you want to have a REST endpoint in Java code. JSON-B and JSON-P both exist in order to give you the ability to kind of parse and marshal and understand JSON structures. And MicroProfile's addition to this collection is the REST client. So JAX-RS has a REST client. It is kind of a dynamic REST client. And what we thought in MicroProfile was actually it would be really nice if you could just annotate an interface and then have the runtime invent the semantics for how you then do the call. So with MicroProfile, the REST client, you basically just have a JAX-RS annotated interface, and at runtime, an instance is created, so you can just make method calls on a Java object, and it ends up being REST under the covers. So at this point, I'm going to try doing a demo. Let's see if I can pull this off. So I have two services. One of them is running in a Docker container on my machine. So I did at least get some Docker in here, even if not Kubernetes. And my REST service is very simple. I'm going to get. Oh no, you can't see my screen. Okay. What happens if I do this? Can you see my screen now? Okay. Okay, so now you can see my screen, right? Okay. You're probably sat there thinking, what is he talking about? It's still the presentation up there. There's no demo. So I've just got a JAX-RS annotated component, and I'm basically going to return a property, and I'm going to fetch the property from another MicroProfile specification called configuration. But I'm not going to do that directly. What I'm going to do is call another service that will give me the value. It's a completely noddy example that I would never expect anyone to use in the real world, but I just want to show some of the programming model. So the get property method, I've got an annotation that says I produce JSON, I respond to get requests, and I have a path parameter, which is the name of the property. And the way I've chosen to implement this, because nobody wants to sit here watching me writing like reams and reams of code to demo things, is I've got a interface, which is the fetch service props interface, and I'm just going to ask CDI to inject an instance. And the way CDI will work out what instance to inject is I have an annotation that tells it exactly which instance I want. In this case, I'm going to go for the vanilla instance, and the vanilla instance just makes the call. And if I open the vanilla instance, it basically gets a REST client injected. And if I look at the REST client, it has an interface service C. I have a getProp method. It takes two parameters, a mode parameter and a prop name parameter. The mode parameter allows me to simulate some failure conditions, which I'm not going to do at the moment, and then the prop name. And that's all I need to do. I just call this interface, and everything then flows through into REST to the backend service. So if I go back, this is my REST service, and I'm going to hit refresh. So if I wanted to find out what operating system it was running on, I could ask it what the OS name is. The OS name is a system property, and it will tell me the OS name is in Linux. And up here, this isn't important right now, but it gives an environment. It tells me which environment it's running in. So at this point, it's running in a Docker container. Now, if I look at how the service C is implemented, I have essentially a CDI bean, and I get MicroProfile config injected, and then I basically ask MicroProfile config what the value is. What this does is it has a search path through different configuration sources, and it will look in system properties, it will look in a properties file inside of your application, and it will look inside the system environment. So the nice thing about looking in the system environment is the way I have in my REST client, when I return it, I'm calling this highlighted item, which is saying, could you give me the property stage? And I'm going to pass that in as the environment. And what I've done in the Docker container is when I launch the Docker container, I hit -E, stage equals Docker, and then I've just written some code that it doesn't know that that's from the environment. It doesn't know that where it comes from. It just knows that there's a property called stage, and it will be present. So when I'm running outside of Docker, I could have a Java system property that is basically stage equals local, for example, and then it will start up, and it will say it's local. And if I wanted to run the Docker container and say the environment was something else, I could set it on an individual basis. Then if you are running in Kubernetes, you can get your Kubernetes deployment to specify these configuration variables as environment variables, and then they're available to the application in a way that it doesn't know. So let's see, how do I get back to my presentation? Okay, so that was the first, first demo. So what we basically saw was the code behind this interaction. This is just a very simple example. I've kind of done one or two. So in Eclipse MicroProfile, when you've got hundreds of services though, rather than two, you really need to have a good way of being able to kind of understand and operate and monitor all of those services. So in Eclipse MicroProfile, we have been looking at specifications for this. So at the moment, there is OpenAPI, which is a way of describing your REST services. And it's a way of describing the REST services so other people can then discover and use your services. There's open tracing specification, which is a way of tracking requests through a system. So if you've got a request from a browser and it goes through 14 different microservices, if something goes wrong, you need to know which of those 14 microservices caused the problem, which one had the issue. And what open tracing can do is you put a header on your HTTP requests, and each time the request goes to another server, it takes that header and forwards it on. So, and each server, when it receives a header, it goes and notifies a centralized open tracing server that the request is in this server. And then if you've got something going wrong, you can look in that external open tracing service, and it will tell you that the request has reached this server, and it didn't go any further, and then you know that that's the best place for you to start debugging. So that's the place where the error is. There's a health check specification which was originally designed with the idea that if you're running in a cloud environment, typically they need to know if the system is in a good state to route requests to it. Now, I think pretty much everyone who's involved in health will admit that the initial specification was a little bit naive, so we are working on an update to the specification, because in a lot of cloud environments, there are two concepts that need to be modeled. One is, are you ready to receive traffic? And the second one is, are you still able to handle traffic? And unfortunately, we didn't have that distinction in MicroProfile Health, so we only have one. So if you're running in, I know Kubernetes has this concept of two different checks. So if you're running MicroProfile applications in Kubernetes, only one of those pieces of information is available. And certainly the way I've written health checks, it tends to be a case of make sure I'm up and running and I can receive traffic, as opposed to make sure I can still process traffic. And then there's a MicroProfile metrics specification. The nice thing about MicroProfile metrics is it provides an API, a REST API, that external monitoring tools can use to extract information about the system, memory usage, CPU usage, things like that. But it's not just providing a REST API to a load of statistics that the runtimes collect on your behalf. It provides a whole load, it provides an API for applications to be annotated with metrics that mean something to them. So rather than it just being a case of you hope that the runtime you've chosen provides useful metrics, you can actually create whatever metrics make sense in your application. Now, originally I was going to show a really good demo of all of this. Unfortunately, that would have required me to have the working Kubernetes system. So I'm actually going to pause this demo, and I'll come back to it. And then the last set are, MicroProfile configuration, JWT, and fault tolerance, which is kind of how services operate and interact on their own. So config is how you would parameterize configuration. The JWT, or JOT, as apparently it is pronounced, allows us to have an agreement between implementations on how security works. So historically with Java, we're very good at defining APIs for doing security things and saying this is how the Java API works. And then every vendor implements it in a completely independent way. So we'll say this is the API for implementing how you do programming, but we never actually then have expressed how, on the wire level, one implementation of Java EE sends credentials that work with another implementation of Java EE. And quite often, they all have different ways of doing it, which are incompatible. So what this specification does is it says, everyone who implements MicroProfile JOT, this is what the JOT looks like. This is how it'll be generated, and this is how it should be processed. And that means that anyone who is using MicroProfile JWT can essentially interoperate. And of course, because it's a JOT, one of the nice things about it is there's no actual reason why you have to do this and understand this format only in Java-based systems. In fact, what's encoded into the JOT is something that would be understood by other languages as well, but there's a few kind of restrictions and flavors that seem to work best because the JWT specification is fairly general. And this, if you're doing security, which I would hope a lot of people are thinking about security in this current day and age, this is a really good way to kind of propagate security credentials between your microservices. And the last one, which I'm probably going to spend a bit of more time doing a demo of, is fault tolerance. And fault tolerance is basically if you're relying on somebody else's microservice and it goes down on 2 a.m. on Christmas Day or Black Friday or any other big shopping holiday period, you don't kind of want to be the guy who has to be phoned up to bring everything back up. So fault tolerance is essentially a way for you to deal with unreliability in downstream services. So instead of it being all hands on deck, it's person whose services downtime is on deck. I've kind of shown config. Okay, so okay, demo. Yeah. Let's see. Where's to go? That's the wrong window. Oop. Okay. Okay, so this is going back to my first service, so I'm going to open the REST one, and the first thing I'm going to do is I'm going to I'm going to do sometimes. So I can say I want this to fail sometimes. It would help if I used the at the beginning, so actually annotation. And when I annotate it with sometimes, I'm going to get this this piece of code running. And what this does is it basically says, I want you to fail sometimes. And what the backend service will do when sometimes occurs is every other time it's called, it's going to return something like a 500 error. So if I go back to here, okay, you'll see there's a HTTP error 500 because it's failed and it's not reliable. So one of the simple things that you can do if something is failing on a failing and it's not always going to be down is do a retry. So maybe that old adage that the definition of an insanity is you do the same thing over and over again expecting different results might not apply to this downstream service. So I've selected to do it with a retry. And then in this code, I just very simply have the retry annotation. And this is saying, if it fails, just try again. So now if I go back and I hit refresh, it reloads. Although it might have reloaded because it was going to work that time anyway. So if I just refresh again, you'll notice it's given me a response. And every time I hit refresh, I'm now getting a response from the downstream server. And that's because it'll either work on the first request or it'll work on the second request. So my refresh is causing an automatic under the covers retry. There was no code required other than just to annotate a method with an at retry. Much simpler than kind of wrapping it in a loop. Other thing I'm going to I can show is I have a timeout, and this one will trigger it to take 2 seconds. The backend will take 2 seconds response, but I'm going to require a response in half a sec. In so in this case, you'll notice it's taking a lot longer. And I've now got a timeout. So in this case, if I've got an error, I've caught an exception, and I've said, okay, I'm going to put this into the log. So the request is taking too long. So what I'm going to do is I'm going to actually say I want to do a fallback. So the nice things about fallbacks is, and you can compose multiple of these annotations. You could do a retry and a timeout and a fallback, and it will do sensible things with that. But in the case of the fallback, I'm saying I want to time it after 500 seconds, but when it fails, I want it to call this fallback method. And the fallback method basically is going to call system.getProperty, good enough, I think, in this case. And then in the environment, it's going to say fallback. So now if I go back and I hit refresh, you'll see it's triggering the fallback here. So that's kind of my indication that it's giving a different, it's actually going to a different thing. You might not remember, but the OS name beforehand was Linux because it was running in a Docker container, and now it's Mac OS because this application is running on my local machine. Okay. I've just had my 5-minute warning. So I'll stop demos. Okay, so there is more to fault tolerance than just those patterns I did the quick demo for. You can also do a circuit breaker pattern using annotations. A circuit breaker is basically, if it fails, it will go into a, I keep getting this wrong, I think it's the open state, and then it will attempt, so it won't make further requests downstream once it hits the threshold, and then it will retry the requests periodically. So if the target service, say, went down for 15 minutes, it would say, okay, I'm going to try one every 15 requests, and when enough of those requests start succeeding, I'll start funneling the requests back to the backend service. And it's really useful if you pair this one with fallbacks, because if the downstream service goes down, if you were querying information and you have a cache of the information and the backend service is giving you more up-to-date information, maybe you can give them a previously cached version of the data. And that's what your fallback would do. But meanwhile, you're not wasting time waiting for a service that isn't available. There's also an annotation for doing bulkheads. I think there's changes coming in how bulkheads work in the next version, but basically this allows you to say, I want to limit the number of downstream requests to, say, 10, and then when the 11th request comes in, it'll essentially pause in your service. So if you have a downstream service that can't cope with massive concurrency, you can kind of make sure you're a good citizen and when it's and don't overload it. I actually remember one of my colleagues went to a customer who had a database issue, and when the response characteristic for their application when the database server went down was to just retry the connection immediately. And this would have been quite useful because when they were retrying the connection, they were basically quadrupling the load on this database that was already sick. So it was already sick, it needed to have less traffic to it overall, and it suddenly saw a 4 times increase in the amount of traffic. So, it was like they were giving someone who was down a good kicking, and bulkheads can stop that. Some of the items in here you can also do with service meshes. The one that's best known is Istio. Open tracing and fault tolerance, retry, timeout, circuit breaker, and bulkhead can all be done in Kubernetes using Istio. We actually have a piece of work in MicroProfile to work out a nice way for these two things to interact, because what you don't want to do is find Istio is giving you retry semantics and your application has a retry annotation, because you'll end up doubling the number of retries. If you say you're going to retry 5 times in your application and 5 times in Istio, you're actually going to retry 25 times in total, which isn't good. But even though Istio can do some of these capabilities, there are some things it can't do. One thing it can't really do is fallbacks, because it can't know, because it's applying this at a network level. It can't know what the appropriate fallback to do is. So it's just a failure in your application. So even if you said, I'm not going to use any of this, I could do it. Okay, so I'm going to skip what's next because I've just been told I have to stop. Okay, so summary. Doing cloud, there's organization as well as technology changes. MicroProfile is very useful for solving these challenges. I skipped the slide about Docker because I got told I'd overrun. But you need to choose appropriate packages. You want to have a right sizable runtime. And oh yeah, we have a load of guides. If you want to know more on Open Liberty, there's a whole load of guides on how to use MicroProfile. that goes into kind of more detail. And with that, thank you, and questions. It's really hard to do a 30-minute talk when you're used to 40 or 50-minute talks. Sorry. Did anyone have questions? I can apologize for not having the Kubernetes demo once more. Thank you for laughing at that one. Okay. If people have questions they want to ask me outside of the context of this room, I will be in the IBM stand during breaks. Thank you. Oh, and actually, we have MicroProfile T-shirts. So if people